While we wait, I tell you that our special guest today, Luciano, over there. Yeah, fresh from Brazil. Deutsche Bahn late by 40 minutes, still made it, really good. Yeah, speaking of that, you all know the book, right? Can you hold this to me? Okay, hands up who knows this book, Fluent Python. Very good. So for the rest, you have till the end of this evening to read it through, okay? Important, because there are only 5 copies, I think, right? That Luciano will really kindly give away. We do not know how. Maybe he needs to like you. I don't know how exactly the algorithm is, but somehow 5 of these books with his signature, which is like plus 100 to your Python skills, are going away. So yeah, I'm Anton. Some of you know me, some don't. This is Leon. It was his own desire to cut his hair like that. Please don't sue me. Don't tell his mother about Coca-Cola though, please. Hi, if you're looking at the stream, sorry. Good. We have a packed agenda today. So we have 3 super cool speakers, diverse topics. I'm sure you know what topics are. I will not keep you busy for explaining this again. But what was not announced that also we have Laisa over there, the leader of PyLadies Munich, who will, yay, stand up, Laisa, who will give away 3 tickets, right, to the Open Search Conference in Berlin, free, just because she likes you. Well, she should like you, I guess. She will explain how we will raffle that exactly. It will be absolutely fair, of course, but still, a little sympathy helps always, you know. Good. So, like, this is possible because Zeiss is hosting us. Let's make it clear. We are a really big meetup. Like, we cannot find the venue. It's really hard. It's above 100 people, difficult. Munich, you know, packed city, difficult. So I guess we need to say big thanks to them, first of all. So thanks to Carl Zeiss. And we would like to hear some introduction about the company and also get ready for our first talk. So please, Lydia, you have the word now.
All right. Okay. I'm okay. Micro is working. Wonderful. Quick question around. Who of you, before coming here today, knew about Zeiss in Munich? Okay, that's not as bad as I thought, and I hope it was not just Zeiss employees raising their hand. So thank you very much that you came today and that you visited us. I live in Munich. I know how much there is to do. I know how much you can explore and learn and go out in the evening. So thank you so much that you choose to come here and visit us today and stay with us for the PyMunich meetup. So I'd like to tell you a little bit about us as Zeiss. And you will be in touch with us much more throughout the day than you may actually know and expect. So when you wake up in the morning and your mobile phone is ringing, what you may not be aware of that about 80% of the high-end computer chips, and actually if you look into smartphones, it will be almost all of them, are operated and run with chips that have been produced with Zeiss optics. So and as your day proceeds, and you know maybe your little dog has a little bit of a stomach ache and needs medication, or maybe your grandma, who knows. About 30 Nobel laureates have used Zeiss microscopes to develop their groundbreaking research, which is partially in life science but also in pharmaceutical and medical environment. So now as we move on, and you want to read the news because you heard about there is a meetup and you want to learn about who is coming, who is talking, and so you need to get your classes. And what you again may not have known that about every second person wearing eyeglasses will most likely have in some form or the other lenses coming from Zeiss. And now it's about time, right, to actually go to work. So you get on your car, you get on the ring, you get stuck in traffic, and happily you can stay there feeling very comfortable and safe. because it is Zeiss methodology technology that's used throughout the automotive industry and beyond to ensure that the really tricky part in your motor are according to specs, and therefore your safety is, assured. With this in mind, right, it has been an incredibly busy day. You had a lot of exciting stuff happening, and it's 4 o'clock in the afternoon. You start getting tired, and you think the one thing that's going to get me through this afternoon and evening is a piece of chocolate. And happily, there's Zeiss there for you, because we have special technology that measures the consistency of chocolate, so that it really has this nice taste and the nice texture that you really like to have for your afternoon rescue. With all this excitement going on in the afternoon, you want to really go and see your grandma because she has cataract. And about 50 million cataract operations are performed each year with surgical systems provided by Zeiss. So you go there, you visit her, and everything went smooth, everything went fine. So don't worry about your grandma. I'm happy. But after such an exciting day, you really need time to rewind. So what do you do when you live in Munich? You trash either the class or you get into the mountains, right, and travel into the Alps and just enjoy the wildlife. And eventually you use Zeiss binoculars or camera lenses to really fully emerge into the nature. Now, freshly rewind, happily you come back into town. And there is nothing nicer than, finishing a nice day off with your friends, going to the movies. At least I like that. What you may not be aware of is using Zeiss lenses, we actually enabled Oscar-winning movies like Titanic, Lord of the Rings, Skyfall. And there is such a thing, and I didn't know that before I started at Zeiss, there's such a thing as a technical Oscar. So considering this, right, we as Zeiss, and if you would meet us in the headquarters in Oberkochen, you could see it. We actually won the technical Oscar. So this is the day with Zeiss. So with this, I hope I convinced you that there are many touch points you may have throughout your day where you get in touch with us. And today, you are even here to visit us. Now, as you might have noticed, we have a wide range of portfolio where we are active. So essentially, we are organized in 4 different segments. We have the semiconductor manufacturing part. We have the quality and research. In the quality and research, we have the measurement machine that we use in automotive, and we have the microscopes where people win Nobel Prizes with. We have the medical technology, and there are 2 parts. We have microsurgery, and I'll tell you a little bit about it in a moment. And we have the ophthalmic devices. That's the one where your grandma gets your cataract treated. And we have the consumer market with the vision care, where you get your glasses, and the consumer products. And what we want to, in the next few minutes, show you a little bit that in all these areas, actually there are touch points where we use machine learning. There are touch points where we use Python. So with this, I'm Lydia Nemitz. I am part of Zeiss Digital Partners. We are located here in Munich. And when we started Zeiss Digital Partners approximately 7 years ago, what the goal was is really shaping the future in the digital age and beyond with Zeiss for its customers. And I just brought one example on what we worked on, and this is coming on the from medical microsurgery. So this is a cooperation between Zeiss Digital Partners and medical microsurgery, where they have also a really great team doing the software development just a few stairs up in the building. So what is the Convivo case? So Convivo is a confocal microscope that's used through surgery for cancer treatment. So what they do is if you have an operation and your tumor needs to be removed, what is done is the surgeon looks into the tissue and tries to remove as accurate as possible the cancer tissue. For this, the usual way is they remove some part of it, You send it into the lab. Someone there, a specialist, is looking into it in the lab and is saying, well, I mean, yeah, that doesn't look good. You should really remove it. Or is saying, no, that's fine. Actually, don't worry. And it comes back. This can take some time. While this is taking some time, you as a patient most likely will be sleeping in the surgery room. So the idea here was, and what Convivo is doing today, is to essentially improve this kind of patient journey by changing the workflow. So what they've done is, with a special microscope, they send the image to the pathologist who can look at it instead of sending the tissue. And then the pathologist can look at it, can give his feedback, and the surgeon can right away start continuing. That removes a lot of stress on your body throughout the surgery. It improves the workflow for everyone involved. And to make this happen, and this was actually a collaboration, and my colleague will come in a moment, between ZDP, medical surgery, and CRT to make the machine learning part of it happen. Because if you look into the pictures through such a microscope, the tissues look different than when the pathologist is looking at it in his lab. And they need to have this kind of similar appearance to make a quick decision. And to find a technical solution to this, it's, as far as I know, it's not yet integrated into product, so it's quite good. Don't tell anyone. To make this happen, a lot of computer vision and machine learning is actually happening under the hood to really fully enable so that the experience for the specialist is as smooth as possible. Of course, there are more words, but I think I told you most of the story I wanted to tell you today. And with this, I would very much like that my colleague Steffen is coming. He's from our corporate research department. And he will tell you a little bit what corporate research in Python machine learning is doing.
Okay, so thanks Lydia for the introduction. Hi, I'm Stefan. So I'm, as Lydia said, working at corporate research and technology. And as you can already see here, so our main task is really collaborating with each of the business units, so that if the business unit has a special task to solve, where they say, okay, we already have really good people, right? But for that specialty, we really need an expert or a team of experts in. Then we work together with them on a project-to-project basis, so that we do some special developments that they can then integrate. Because as you saw maybe on the first slide for Zeiss, it's all about performance, excellence in technology, and which as well comes usually with a price, right? But then you want to bring something extra to it where people benefit. And to give you some examples, so one for each of the business units, for SMT, semiconductor manufacturing technology, for them, in the production, everything is about quality. So the tiniest defects need to be found in advance so that the machines operate smoothly. And the example, so this is the extreme ultraviolet lithography, uses lots of mirrors, right? So the light is produced here with 13.5 nanometer wavelength, and is then transported to the system. Up there you have the semiconductor mask, and then it shines down there on the wafer. But each of those mirrors needs to have a surface which is perfectly smooth, and this produces lots and lots and lots of data which you basically can't examine manually. So there we had quite long projects to do machine learning-based production optimization, which saves machining time when the mirrors are polished, and as well discards mirrors if they are not usable. Then for IQR, now this is an example. So throughout Zeiss, so we as well have a team which is focusing on optics development. And what I didn't know before joining Zeiss, it's quite a huge problem if you take a look at living cells, that they die because of phototoxicity while you look at them. So the light that shines upon it makes them decay faster than what happens with the sun. So our colleagues in the optics team came up with this so-called lattice lighted optics, very special type, which then allows using basically every tiny bit of light and then make images of, for example, how cells split up. And this is mentioned it here too, was something that won Zeiss, the so-called Deutsche Zukunftspreis, German Future Prize, in 2022. Then Lydia already talked about cataracts, which are a huge problem, especially for elder people. And these operations are performed very often. And one indicator for the quality of how that operation went is basically the time that was spent. So for each of the phases of such an operation, you want to know, like, what went wrong, where am I sort of on par with my surgery colleagues. There's been a project where machine learning was used on video data to segment those phases and to understand, like, how long did each of them take. And then this can be uploaded, examined, compared to gold standards, and see what happened. So I was pretty surprised to learn that doctors, surgeons are really open to this. So they're very willing to compare and compete with each other on how can I improve and how can I do better. And this is the platform that supports it, and is driven then by rhythms that we've developed. And last but not least, very technological product. So this is the VisuFit, which is a device that you can find at opticians. So if you want to choose a different frame for your glasses, and if the glasses need to be centered so that they fit to the point where you look through them, then there's this device which houses 9 cameras up here in this arc, right? And then takes multi-view images of your head and then generates a 3D user avatar. This is as well one project that we then collaborate with ZDP, where this reconstruction happened at CRT, choosing a suitable frame. So the algorithm for this to recommend a frame that hopefully nicely fits your face and your taste was then handled by CRT. Nowadays, there's a lot happening in machine learning, and a lot of companies work with the algorithms and make value out of this. For me personally, I joined Zeiss only 1.5 years ago, and what I learned there as well, how interesting it is that you have so much under one roof. So basically, each of those units produces machines that produce data. So data is there basically in abundance, which can be used to compute new insights based on that data, to develop new algorithms, which produces some sort of deliverable. Can be an algorithm, can be a complete system. And this is then again used by the business units, right? So you can do this all integratedly here, not relying on external data or anything. Okay, so far from CRT, Corporate Research and Technology. And we're switching to the meetup. And keep things short, I wanted to introduce Ali, who will talk about a revolution. So basically, revolutionizing machine learning with federated learning. And he's going to talk about Python and the Flower framework.
So hello everyone, my name is Ali and I'm a working student data scientist at Zeiss. My background is of computer science and I'm doing my master's at TUM in the program of data engineering and analytics. And today I would like to present to you how to do federated learning specifically using Python and the Flower framework. So first, before we go into what federated learning is, first I would like to give you some sort of motivation of why we need federated learning. So machine learning is a big thing nowadays, and this involves using data and extracting patterns in order to do different kind of applications, some of which could include basically detect.
Just this screen sharing and share against the screen your window, and that you are where is this one?
This one.
This one. No, this one. Why it's in?
And then when you
Oh my God! I don't know how to. You're sharing this screen, so can I press
Yes.
escape? And this is your. This is a presentation, yeah.
Yes.
If we, how to first sharing. Sorry, I interrupted you, but it's not streaming. And then this is present, share screen, then share screen, then window, and you are sharing this one. Oh my God.
We could.
Okay, let's maybe. But what if we all right.
You can just share like this.
Yeah, you can just continue. We can
But
just how how you put this to
basically, you need to share.
my God. Right? Yeah. Now it's okay. Let's continue. And yeah, let's continue.
So before we go into what the federated learning is, let me give you some sort of motivation. So machine learning is a big thing nowadays, and it involves using data in order to extract patterns, in order to use them in some sort of varied application. This could include maybe detecting diseases from medical images or signals, or maybe doing image classification. Regardless of the application that we want to do, basically we need data, and data might not be available. Why is that? Data could be secret, it could be private, and it could be something that you don't want to put on the server in which you're basically doing the actual machine learning. So without an example of this within Zeiss is basically, and this basically touches upon the part of where data could be private, is where Zeiss has a collaboration with a pharmaceutical company, where it is basically trying to detect eye diseases. And in order to do that, you need medical data, and medical data comes from hospitals. However, hospitals have patient confidentiality, which basically prevents them from giving you the data. If you do not have the data, how would you detect eye diseases? So you need some sort of workaround. And before we go into the workaround, let's just say something. So in regular classical machine learning, in a centralized manner, what we would usually do is that we would have basically a server, we would have the data, and then we would have some sort of model that actually does the application at hand. So if we don't have the data, this model cannot be applied, so we need a workaround. So the workaround basically comes in the form of federated learning. So how is this different from the centralized version of machine learning? So in that case, it's basically a distributed form of machine learning, where basically we have two entities. We still have the server, but rather than like in the centralized manner where the server does everything, here the server is more in coordinating, and then we have the clients. And basically the clients are those who own the data, and the data never leaves the clients. So basically it's the model that is sent to the servers rather than the data being sent. So what happens is first that basically the server initializes the global model, it sends it to the clients. The clients then, using their own local data, they train the models, and then they create their own local models. And then these models are then sent back to the server, and now the server has a bunch of local models, and somehow these local models have to be combined into one model. And there are many aggregation strategies that could be used and will be discussed in the talk, but for now, let's keep it general. So the server applies some sort of abstract aggregation strategy and then combines all the models together, and now we have an updated version of the global model. And then this global model is sent once again to the clients, and then basically they train on this refined model, and basically this cycle repeats over and over again until the performance of the global model converges. So now that we gave basically an introduction of what federated learning is, let's now delve into the more important question about in this talk, which is how to do it in Python. So rather than reinvent all of the logic needed for the client and the server, there are basically existing frameworks that prevent us from reinventing the wheel, such as Flower, TensorFlow Federated, PFL, Fate, OpenFL, and that's just to name a few. The one that I would like to focus on in this talk is basically Flower. Why did I choose basically Flower? Because in my opinion, it has some interesting features. One of them is basically it's modular and customizable. So what does that mean? So Flower comes with a set of features. But what if you want to add a feature or modify an existing feature? So Flower allows you basically to extend its classes and basically override the functions and modify any functionality or add any functionality that you need. Also, unlike other federated learning frameworks, where it is dependent on a specific deep learning framework, such as maybe some frameworks are dependent on PyTorch, some are dependent on TensorFlow, Flower is compatible with any framework, making it convenient. Also, it is in general popular, meaning it is backed by a strong community. So if you run into problems, there is a strong community backing Flower. With that, those are basically some of the reasons why I chose to speak about Flower. Now let's introduce what Flower basically provides you. So Flower provides us with client and server classes, and these basically contain the logic that's needed for the clients and server entities respectively. Also, it provides us with a set of algorithms, and these algorithms basically include the aggregation strategies that are used by the server in order to aggregate the local models and create the updated global model. Also, one interesting feature is a simulation function, and this basically allows us to run the federated learning setup on a single device. Why is this interesting? This is interesting because if we don't have still an underlying cloud infrastructure, we could start by testing our federated learning setup without having an infrastructure and then implement the infrastructure later on. Now, before going into more details about Flower, I would like to introduce a use case that I personally worked on at Zeiss. And through this use case, I'll explain how you could use Flower and how we use Flower, Python in general, and Flower specifically to implement federated learning. So this use case is the diabetic retinopathy detection use case. And diabetic retinopathy is basically a disease in the eye that is caused by diabetes. In this use case, we use the public Kaggle dataset, the diabetic retinopathy dataset. And while this dataset, basically this dataset allows us to do multi-classification, meaning we will be able to actually detect the severity of the disease, we chose in basically this use case to deal with it as a binary classification problem, where we would just detect whether a person has diabetic retinopathy or not. And in this use case, we also experimented with a number of machine learning models, such as the vision transformer and the MobileNet. And the model that was most successful was the MobileNet version 2. We used a pre-trained version, and we basically why the MobileNet is good is because it's lightweight, but it still achieves performance that is comparable to large models such as the ResNet. And finally, we use PyTorch as a deep learning framework, and how basically Flower in general deals with the deep learning framework. So Flower is built on top of PyTorch, and while Flower provides you with the federated learning logic, it then uses the PyTorch in order to train the deep learning models. Now let's basically see how Flower was specifically used in this use case. So as I said, Flower provides us with client classes. Basically, those classes basically provide you with the client logic that is needed. This class that we used was the NumPy client class. And going back to the fact that Flower is customizable, in our use case, we had our own model trainer class that we were using. And in order to use that with basically the NumPy client class, we cannot use it directly. However, as we said, basically we could just extend the NumPy client class, create an implemented client, which is a subclass of the NumPy client, and just override the fit and evaluate functions in order to basically train and test using our model trainer. And thus, simply, this shows how Flower is customizable. It comes with specific features, but we were able to basically modify it to suit our use case. Also, it comes again with server logic, server classes. There's the standard server class that again encapsulates all the server logic. And another class that is interesting is the client manager, the simple client manager. And this class is basically responsible for picking which clients train in which local model. As we said, federated learning runs for several cycles, but not in each cycle all clients have to train. Why is that? Basically, maybe not all the clients are available, so we would just have to pick a subsample. And how Flower does it, basically, it does random subsampling. It picks a random set of clients. However, a student that was working prior to me on this project wanted to experiment with ordered sampling. Again, that's not possible with the simple client manager class that is provided by Flower. However, we could simply just create our own client manager class, extend the simple client manager class, and override the sample function in order to do sampling or in an ordered manner rather than random. And then we create, now we have our own client manager. In order to be able to use it with a server, we cannot use it directly, but we could just create our own server as a subclass, override the init function, and then basically pass our own client manager to it and be able to use it. Now let's take a detour and investigate some of the challenges we faced in this use case. These challenges are basically common challenges that are faced in federated learning, which is why I want to discuss them. Also, through discussing how we overcame those challenges, we'll go back to Flower and show you how we use Flower to overcome these challenges. So the first challenge is basically the data imbalance. And this basically is often present in federated learning because federated learning deals a lot with medical use cases. And in medical use cases, data imbalance tends to be present. Why? Because simply most of the patients do not carry the disease. And this was seen in our use case where 73.5% of the data points did not carry the disease, did not have diabetic retinopathy, while 26.5% had diabetic retinopathy. A second challenge that we faced was basically dealing with non-independent identical data. And what does that mean specifically in our use case? So if we look at the image on the left, basically, first let's start with the right. This is if it's independent, identically distributed, each client would have the same percentage of data points that have diabetic retinopathy and don't have diabetic retinopathy. Here, 70% don't have diabetic retinopathy, while 30% have. And this percentage does not differ from one client to another. However, in a non-ID case, this percentage could differ from one client to another. And why is this an assumption that we worked with? Because simply hospitals don't have to see the same number of patients carrying the disease. The percentage could differ from one hospital to another, and thus we chose to simulate this. We started with IID data, and then we simply simulated in order to create this non-IID case. Now, with these being some of the challenges we faced, how did we overcome them? So simply the choice of aggregation strategy matters. So let's now discuss some of the aggregation strategies that are used by the server in order to combine the local models into one updated global model. So the first strategy is basically the federated averaging, which is basically a weighted average of all the parameters of the model, and the weight is basically dependent on the number of data points that the client has. So the more the data the client has, the more influence it has on the weight updates. And this is a common strategy, and hence it is available in Flower, which is good. However, going back to the challenges that I discussed, we face data imbalance, and this is technically not suitable for data imbalance. So how would we overcome this issue? So simply let's use a different strategy. One strategy could be federated average balanced, and this is a modification of federated average, where the weight rather than the weight being computed as basically the number of data points that the client have over the total number of data points. Let's just consider the minority class. So it's how many data points of the minority class does the client have over the total number of minority class data points that are available. And this is more suitable for data imbalance. However, as a disclaimer, this is not a commonly known algorithm. This was developed by a student who was working prior to me on this project, and hence it's not available in Flower. But again, simply because Flower allows us to basically modify its functions, we could just extend the federated average class that is provided by Flower and simply override the aggregate function in order to create the logic that I just explained. One other strategy that is commonly interesting is secure aggregation. Why? Because in federated learning, we said we cannot give the data, we cannot have access to the data, so we send the actual model parameters. But what if we can tell something about the data from the model parameters? This would be an issue, and we would not want that. So in order to prevent this, we could use secure aggregation, and secure aggregation can be implemented in many ways, one of which is differential privacy, and this is the one we used in our use case, where you basically add Gaussian noise to the model parameters in order to mask their values. Of course, this introduces a trade-off between the privacy and performance, meaning the more noise you add, the more it would degrade the performance, and vice versa. And this is also not available in Flower. However, we could simply just, again, extend the aggregation strategy and override the aggregate function in order to implement secure aggregation. One final algorithm that I would like to discuss is basically fetstop, and this basically involves the local training of the clients. So fetstop, the goal of it is basically to stop while the client is training and creating the local model, it prevents it from local model diversion from the global model that was sent by the server. And what happens is that while the local training is going, the dissimilarity between the models is measured, and when it exceeds a certain threshold, and in our use case, we use the threshold of 0.3, it would simply stop the local training. Now that I basically demonstrated how we could use Python and specifically Flower in order to create federated learning, I would like to show you that doing this using Flower in our use case did obtain results, and so it was not simply we trying to create something and it did not work. It worked fairly well, and what I'm presenting here is basically the ROC curve of two setups. So first, there is the centralized machine learning setup, where we have a single server and the data is available, no federated learning is applied. And then there's the ROC curve of the federated learning setup, where basically we have 3 clients. We're using Fed average balance and differential privacy together as aggregation strategies. And both are basically applied on the same use case, which is the diabetic retinopathy use case. And as we can see, basically the performance of the federated learning setup is comparable to that of the centralized training. So what we obtain basically is performance that is comparable to the centralized training while not sacrificing data privacy and still keeping training in a federated manner. With that, I would like to conclude. So what to take away? So we discussed why we need federated learning, simply because in order to do machine learning, we need data, and data might not be available. It could be secret, it could be private, or simply we might not want to share the data with the server. So we would simply use federated learning, and federated learning is basically available in Python through frameworks such as Flower and TensorFlow federated. And then we discussed the diabetic retinopathy use case, and through it I showed you how you could use Flower. And then I demonstrated some results to show you that in our case, this actually worked. And with that, I would like to conclude my presentation. And now I can answer any questions if there are.
Big thank you, Ali. Q&A round. This is the first step. What kind of did you use for that with the dropout curve?
So basically, we use the combination of 2 aggregation strategies. We used the federated average balanced, and we used differential privacy. So federated average balance basically solved the data imbalance part, and then we also applied differential privacy in order to make the values of the model parameters mask, basically.
So what about the recall curve or about recall?
Excuse me?
Like false negatives, how important is it?
Yes. Yeah. In our case, so this is basically the rock curve, but one other interesting metric that we chose was basically the recall, the sensitivity, because in our case, it is important to be able to detect whether a person has diabetic retinopathy. If we make a mistake in basically the person, we say that the person has diabetic retinopathy but does not have, it is a lighter mistake. But if a person has diabetic retinopathy and we say they don't have, this basically could lead to blindness. He could get blind, so this is more critical. So in our case, detecting basically the positive class, the diabetic retinopathy class, was more important.
Thank you. One more question. I see over there. Yeah.
Thanks for that great talk. One thing I never heard about before, which sounds super interesting and useful, is that differential privacy. And I was wondering, how did you choose the variance of the masking distribution of that noise?
So
I could imagine that the result degradation you are experiencing is highly dependent on that variance. Did you try that out?
Yeah.
To choose the parameter? Did you just take a walk?
So yeah, in general, like, ideally, what should be the case is that the variance of the differential of the noise should be corresponding to the variance of the model parameters. But we basically tried different values, and then we chose the value that seemed more appropriate.
Thanks.
All right. We have time for exactly one more question. I saw this. Because lady first. All right, the lady.
Okay, thank you. Just a quick question: which model did you use for the classification?
So we use the MobileNet version 2. We use the pre-trained version of that. And we also experimented with other models, but this was the model that was most successful.
Thanks, Ali. Good job. We make a break, 10 minutes. After the break, Laisa will raffle tickets for the conference. And after that, we will raffle the books. So stay tuned, 10 minutes.
you remember me? Yes, I remember your face. Where did you meet?
but maybe it's good for some of you. So what we're gonna do today is I will talk a little bit about the Open Search Conference. It's happening in Berlin in May 6 and 7. And it has a lot of talks, amazing talks about data, about open search, everything you can go around data. And we got some free tickets thanks to our Open Search Conference organizers. We got 3 tickets, and maybe some of you want to go there. So it's opportunity. It's a free ticket. Normally the ticket costs about 220, some cost like this. So let's see. For that, I prepare a small game. I can hear myself. A moment. Okay, I don't know. I will mute myself. Sorry about that. So we have a lot of people here, not enough, I guess, because of the internet. But please put a name that we can recognize you after all, because it would be hard. So, PyMaster, I hope you know who you are. Maybe many of people here will be PyMaster in the end. But don't worry, it's not really super technical, it's something fun, and I hope that maybe I already give you answer for some of the questions. And I think we can slowly start if someone is still logging in. Let's give it a chance. We have 22 people. Very, very good. Yeah, I will be there. So it's also a condition that you attend my talk, maybe. But it's 2 days, and it's a very beautiful venue, and I think it will be very special. The first edition was in Seattle, and now they have abroad to Europe and also to India. And we are lucky that it's in Germany and in Berlin, which is not so far. So we have 35 people are entering. I will count some seconds. But enter, enter, enter. Does your friend gives you internet? I'm sorry. I would give, but I feel 100 people, my internet would be over. 43, 43. Ooh, we're getting there. It's okay. I will just look. I don't see anyone entering. Raise your hand if it's urgent and you couldn't enter, because I will start some. Yeah, let's start. Let's start. So, yeah, databases. So we're gonna talk a little bit about database, maybe other things. It's a very short game. Just want to see how we can go. This is multi-selection. What is the right name of the Postgres skill? Postgres SQL. Can you see? Can you see? Please answer. I am blocking people. Not intentional. I don't have a favorite side. But yeah, so the right ones are Postgres. Actually, I think that was the original name, and later it was just SQL because of support to SQL. So we have Cabra da Peste. Wow, I have some idea. Who could this person be? So let's continue. But we have two, so we can see that some people are going well and everything can happen. Where the Open Search Conference is happening? Answer fast. I try to give you some tips. It could be still hard, I know, but I try my best. So we have 22 answers. Some people are still not sure. So it's not in Munich, it's in Berlin. So if you win, you go to Berlin, and it will be very fun. So next question is, Cabra da Peste is still gonna win. You are there, Dante, as well. But the other people are coming. So let's see. What is the name from the first search engine? This one's hard. But I already present this, and some people got it correct. Don't tell. Yeah, the first search engine is actually, it was not Yahoo. If you thought it was Yahoo, it was not Google, it was Arki. And also not. So JT, everybody was gone. Who was in the board? You can come back. I think you are almost there. I know this was a hard one, but maybe there are some easier ones coming. So where does the name of the scale come from? American newspaper, scientific paper, TV show name scale, maybe a meetup event. What do you think? This is also kind of historical. So there was this bunch of databases that were not SQL. And someone just said, hey, let's have a meetup. And okay, what we call all these databases, Cassandra, any other databases out there. And they just meet up together and they say, okay, we are SQL databases. And that's the name was in the end. So it didn't come from research or neither the American newspaper. The things are changing. Max is the first, Kita is second, and the rank is the third. So let's go, let's go. Which database does not belong to the family? Did you just say family? Yeah, actually, MariaDB is a SQL database. It's a fork for MySQL, and this is actually from the same creator. He has databases, and one is MariaDB. And this SQL database, and the other ones are considered NoSQL database. So we are advancing. Don't worry, we're almost there. And this is multi-select. When is the next OpenSearch.com in Europe? When? Did I say? Did you see? If you have a photograph memory, you probably saw it. But maybe it's in Christmas time. Maybe it's during Oktoberfest. Or maybe it's in May or in June. You have to answer fast because some people got correct. Oops. This was a tricky one because I put it wrong. But you have to forgive me. It's in May. But sorry. A lot of people are arguing. Maybe it is to give a chance, you know? I said it's not technical. How many databases are out there? Every day is a new database. How many you guess are out there? This one is right because I proofread. Yeah, so we have about 343 databases, not 1,000 yet, but many companies. Okay, let's go. Don't worry, we'll have books too. Maybe you not even go to Berlin. Who would like to go to the open source conference? Please don't think so hard. Okay, 31. I think it's good. I think some people gotta give up. So, yes, this one was right. Phew. So let's go. Take it easy. So, DJ, you got DJ. Ariel, you got it. And Hazel. Woo! But please don't forget, it's in May. So if you thought it was a Christmas, yeah, talk with me after. I will give you the tickets and enjoy the meetup. And I hope you will do another raffle for the books. Stay tuned. Woohoo!
Thank you. So, without further waiting, Thomas, where are you? Here you are. Ready? Thomas. You have the microphone? No.
So do I speak into this?
Both. Very important to be both worlds. So, it's okay. Thanks. So we do this talk. After this talk, we will wrap up. Luciano will give his talk, and then we have some more beers. That's the let's Streamlit.
Okay.
Okay, ready?
Yeah.
Stage is yours.
Thank you very
More
much.
applause.
Neat. Okay. Thank you very much for being here. My name is Tomas. I am a software engineer in Allianz Global Investors, and I want to talk today about Python, which is a front-end framework for Python. And basically, using this framework, if you're building data science apps or whatever, it's going to make your job much easier and quicker. So the agenda for today is I'll talk a little bit about my team, what we do, in general, also about front-end frameworks, and then I'll move over to it and do that well. So first, about the team within Allianz Global Investors, who are our clients? Our clients are big institutional investors with a company. So they have accounts of over 100 million euros or dollars. And our job is to reduce the investment risk in the portfolios, right? So what we do is we incorporate financial instruments like options, futures, and swaps into their portfolios and try to hedge market volatility. That's what my team does. I don't know very much about the finance. In fact, I just program. So I've programmed in different languages, Python, JavaScript, Java should be also there. And I've built front ends also in these different technologies and different frameworks, React.js, I've even a straight jQuery imperative with Django, with RShiny, and so on and so forth. And the reason I'm holding this talk is because Streamlit is the very first front-end the framework which feels that simple to use, like so simple that it really blows your mind. So let's talk about my team. So my team they write financial mathematical algorithms in Python and in MATLAB. They're very smart people. But if I talk to them about writing front ends, and especially this is them on the right here, if I tell them about writing a JavaScript framework code, that's what they look like. And when we speak about using Python for developing our own front ends, then they're more receptive. They're like, okay, perhaps I'll play along with you. The other thing is that if I introduce a front end in JavaScript, they will never touch it, and I will become the only one maintaining that thing. And that is horrible for me. I don't like JavaScript very much. And on top of that, I will become a bottleneck in terms of the team, like who's handing over work to whom and so on and so forth. They'll be just terrible for productivity in general. And let's say we stay within Python, right? So there is different frameworks for front, for backend development, for REST APIs, and building just web, right? And the thing is, you get into this full stack development mode where you're writing a front end, you're writing a back end, you have this client talking with the REST to your algorithm, which is wrapped within this web application. You have to deal with status codes, recover from the status codes. If you can, you have to deal with timeout. You have to deal with serialization or deserialization. Some frameworks take care of this for you. It's not always the case. In a corporate environment, you also have to deal with authentication, secure communication between services and API keys and whatnot. So you have to take a step back and think about like what is it really that you're trying to do? You have your algorithm, you want to write a front end. Why is it so complicated? Why is my colleagues' heads are already spinning with this information? And that's why I encourage you to try out Streamlit. be like, okay, is there a simpler way of doing all this? And this is where we go over to the code part. And I try, what I'm gonna do is, I'll show you a simple application and we'll go step by step and see how Streamlit does this math. I'll need to probably sit down here. So I can click my way through. Let's see. I guess you see it. What I have here on the left is Visual Studio Code. On the right, I have my browser. I prepared a little app. It is 10 lines of code, and I'm going to run it. And this is a simple app for this occasion. It's called the Beefy Algorithm app. And you see, it's very simple. It has a title. It has a date input. I can select the date. This is like built in from Streamlit. You don't have to do much of anything here. And then there's a button to run the algorithm, right? So what you see when I click on this button is basically it shows what date I selected over here. So if I select a different date, I get a different date selected. So good so far. Let me explain the first principle of Streamlit is that you have to embrace scripting. So this is on the left. This is a script that runs from top to bottom. And really, oftentimes you're writing just scripts. And you have to weave an interaction. But in the end, it's just a script. So what I'm going to do, place a breakpoint over here, and click again on this button, so that you see what's happening under the hood. And it's that Streamlit is running everything from top to bottom. You see the app is grayed out on the right. It means it hasn't really rendered much of anything. Going step by step, go here and say, okay, what happens when it says render that title? Then on the right-hand side, you see the title has been rendered. The next thing is the date input. Then there is the button. And if the button has been pressed, this is really just a Boolean variable. You see, you have to think about the simplicity of this thing in the first place. And if the button has been pressed, it goes into this block and it does another writing. So this st.write is writing some string to the right-hand side. And I think the really cool thing that this simple app shows is that there is no weird widgets that you're getting as a return type. This some date is just a date date object, right? Let's click it again. Clicky. Here we go. Some date. What is it? It's just the date object. Button press, Boolean. That's it. There is no widget. There is no callbacks. There is no HTML IDs. There is none of that clouding your app. So it's really straightforward. Good. So in the next step, I'll actually call this Beefy algorithm that I've been talking about, right? So Beefy algorithm. And this Beefy algorithm, I'm going to program you with a single hand. Some date. It takes a date. I'm going to pass it a date. And it returns a data frame. And okay, just so you know what's happening under the hood, like VS Code imported this for me. That's good. I'm gonna go there and see what's happening under the hood there. This Beefy algorithm is doing a lot of work, sleeping for 5 seconds, and then returning just a data frame. Very simple function, but it gets the point across. It's a slow function. And once I have the data frame, I'm gonna write it out also to the front end. So on the right-hand side, I can say always rerun. I'll remove the breakpoint from here and just let it run. When I click on run algorithm, you see on the top right, it's computing, it's thinking, and finally you get here like this table. That is this is the data frame that I wrote. It's cool that I didn't have to write an actual HTML table, iterate over some sort of items UL items and start printing stuff out. Comes out. Everything comes out of the box for you. And I didn't also have to call a specific function to write to the front end. This is all very simple. You see that this data frame has also a column that's called value, and for that there's also built-in, let's say, draw line. I think it's line chart, and let me quickly write this out. The value. There we go. Run the algorithm. We wait for 5 seconds, and then it's going to print out the table. We also want to see, there we go, the chart. So as you see, quite simple. This is 15 lines of code, and we already got plenty of stuff there, including the DVI. Very good. So I'm going to put a breakpoint here again, and just to show you what's happening. Every time I click on anything, it's going from the top to the bottom, including this call, which is very slow, and then it returns. Yeah. Okay. So how am I going to write a front end that feels really, really interactive, very snappy? If you have this slow function here that's blocking, so to speak, the rendering in the middle of it. And that's where, if you've had slow functions in the past, you might have used caching. So Python comes with its built-in caching functions. And this is the solution too. It's just that Streamlit will provide its own built-in caching. So this is the other, let's say, important concept here. And it's to use the caching that comes with Streamlit. The way to use it is as a decorator. It just wraps that function, and we can reuse it as if nothing had happened. So let's run it again. It's running for 5 seconds. Now we get a nice message here saying it's running the beefy algorithm, right? If I go to a different date and I run it, it's saying again, run beefy algorithm. And now if I click again on run algorithm, it's instantly rendering everything. It seems like it's not doing anything really, right? But if I put a breakpoint in here, you'll see that it really is running from top to bottom super fast. If I go back to the 19th, I'll disable the breakpoint here. I go to the 19th, it's immediately there. 20th, run algorithm is immediately there. So this is how we get this feeling of really a very, very snappy, interactive app like you have in JavaScript, but writing only Python. Very good. I think this is all that I want to show you in terms of a code. The next thing, I'm going to expand this now. Let's see. Let me expand this. I talked that you can ship fast. So let's imagine that this is something you can share with anybody, right? This is a public, this is just your work. You want to just publish it online for everybody to see it. The Streamlit team has added this button here called deploy. So I'm going to click it. And they have this option to go straight to the Streamlit cloud and deploy. You can click deploy now. And I'm not their salesman or anything, but this is very awesome to me. And here you select basically, where is your code hosted? What branch would you like to deploy from? What is your main file? And then do you want a specific URL? So do I want a specific URL? Yes, let's use something. Right, anything really, but you get the point. And you can deploy and start doing the thing. So your app is open. If you have to deploy something in a corporate environment, this is pure magic to you. URL. So I share this with you now, and you'll be able to open the app and you see whatever I see. I mean, it's a triple application, but imagine each one of you have your own use cases, your own research stuff you'd like to share, and how cool would that be? Since it takes a little bit, I'm going to perhaps go back to the presentation, come back here when it's ready. Yeah, but that's good enough. So, what is cool about all this? So remember, we're not dealing anymore with status codes. We're not serializing, deserializing our own messages. We can ship things fast. We can get everything out fast. There are no more language boundaries, framework boundaries between our application. And it means, in my team at least, I can empower everybody else to do content as well, and scale this team bandwidth, not be bottlenecked to myself only. And I have less overhead managing these individual microservices all over the place. And that's excellent into my team. And that is it. Thank you very much. Try it out. And I'll take questions.
Great questions. That was the first one.
My slides? That would be cool. My slides are from Google.
Oh.
Say it again. Yes. So all the plots you usually do have in Jupyter or whatever, they're all there. Plotly, yes.
More questions? Please.
Cool talk, thank you. So about deployment, when we use own cloud servers or VM, how does that work?
Yeah, so what we do is you have to get the port. So the port has to be open. If you've deployed other applications, it works similarly. We work in single sign-on. So that means only the people who have access. We can manage Azure cloud, who has access and everything. And deploy it on Kubernetes. And there's no real magic there. If you deployed anything else, you can deploy this.
Senor Doctor has a question.
Did you stumble into any limitation?
I would say yes. There is in the multi-page setting. So you can have if your app grows bigger, you want to start multiple pages. And there is some state management that you have to do manually, and this starts to bear on you because it's not as simple as it started out, right? So I think if you already know from the beginning that the app is going to be super big and complex, this is not the right tool for your job. But if you want to get something out quick, this is exactly the right tool.
Okay, last question over here.
Thank you for your talk. Imagine you have two buttons, you click one button to launch one task, then you click immediately another button, you can launch another task. Is it limitation or it's equal?
So this is not a typical, let's say, it's not a typical use case that we will find many examples of. I tried to play a little bit with the schedule to see can I schedule these tasks and sort of have like concurrent or what's it called, cooperative concurrency between these different async.io tasks. But this is not really like out of the box, coming out of the box for you. Yeah. And we hinted out that perhaps it's already online, so I'll just refresh the page. Soon they'll open. Sad.
All right, so then we're through. Big thanks.
Thank you.
Great job, Thomas. Thank you very much. So our plan tonight, we still have one more talk in our raffle of the books. And if you happen to have Fluent Python book, because I already received this question during the break, yes, you can get it signed. But you will need to answer to some questions, maybe. So we will have a break now, like 10 minutes, but this time really 10 minutes. Alarm unlock will ring at some point, so we need to be more quick. Before we go to the break, this guy has to go to sleep soon. Stand on the desk. Stand on the desk. So we say thank you to our little participant, and he goes to bed because his mother By the way, he was sitting next to Luciano long enough, so if you have a parking job, probably can do some basic learning. So 10 minutes break, let's do it.
Yay.
just for your mood. We have them here. I'll start it. Yay! You can pass. Whoever wants to have one can have one. It's just for our mood. Now, here is how we're gonna raffle the books. It will be not easy, especially because it's dark, but then it's a bit magic as well. We have N books. Somebody knows how many, somebody doesn't, but it's enough, I would say. It's a pretty standard book. I don't think it needs an introduction. Fluent Python is everybody either read about it or heard about it or read the book itself. So
Number 2.
it's number 2 in the most gifted categories. Let's make it number 1, right? Yeah. After this raffle, it has to be number 1. So we are really happy and honored to have this opportunity today, and this is how I suggest we do it. To be absolutely fair, we will use random.org plus the sympathy. And we want to have numbers of everybody. Then we can also count how many people we have right now. So let's start from Laisa here. She's number 1. Say 1. 2. If you don't want the book, or you have it, or you already read it, you can just say, I know it. I know everything. I have it, or whatever. 3. Hey, it's difficult. Yeah, I know it's difficult. You need to count. It's a bit of math. A bit of math. Okay. Yeah. You need to remember your number, by the way. You need to remember your number. 14.
I got it from a file lady some years ago. It's much nicer.
What's the chapter 3 name?
Which edition?
Oh my God. Okay. 15. Oh, we're getting professional. Eugene.
I know everything.
Good. Yes. No. Ah, man. Yeah. Do you have any more basic books? Okay, 27. Next. Okay, it's ad hoc now, self-manageable crowd. You can do that.
33 in 5 minutes.
Good. We are getting some speed here. Next row. Remember your number. Come on. Louder.
55, 56, 57, 59.
The louder you scream, the more probable that random org will pick you. Come on. Good. Wow, that's a big crowd. 66 next. Good. Good. Come on, we need some speed. Let's go. Almost done. 77, where? Here. Okay, next. 89, anywhere? Can we get more colleagues to get it up to 100? Or actually, the less people, the better the chances. Okay, so what was the last number again? 89. 88. 88 is a final saying, yeah? 88. Nobody changed their mind. No. 88 it is.
Okay.
Do you want to win a book, Luciano? No.
79.
79. Who is 79? Stand up. Okay, this is the first one. So we need to remember you. So if you know some song or dance, you can perform so that everybody remembers you. You don't have to, though. And now we need a bit of tension. Come on. The next one, and
32.
Huh?
32.
Where? Ah, yes, 32. Who is 32? 32. What's your name? Daniel. What's the first winner name? Jürgen Daniel. Very good. Congratulations. Should you do the next one, Luciano? And 25. Who is 25? Yes. Look, Luciano is going to these conferences often. So next year he will check. You have to read it, really. Otherwise, you need to give it back with a shame. So. This was 3 books, yes?
What's his name?
What's your name?
Johannes.
Very
All
good.
right.
So let's go for the next one. Attention, 65. Who is number 65? Alex. Now the last one. This will be difficult. Please hold your thumbs. And please, 76. Who is that? That's who? Congratulations. Name of the winner? Name? Alex. Okay.
2 Alexes.
Concentration. It's random is not so random. All right. Then I think we owe a round of applause for Luciano for bringing this book in the first place and for writing them into seconds. Stage is yours. If you are ready, then we are very much looking forward to it.
I'm ready. Thank you.
Very good.
Well, first of all, I want to thank everybody. I want to thank Anton and Laisa. During the pandemic, I was missing, I loved to come to conferences and meetups and go to a lot of meetups in Brazil where I live, but also in other places. And during the pandemic, we couldn't do that, but I was invited by Laisa to speak online at a PyLadies Munich event. And so this started my connection with this city, and this is the first time that I actually come to this city. So I'm really happy that this worked out. Last night I was in São Paulo, and tonight I'm here talking to you. I'm very excited. Thank you so much. I'm gonna co-present with a friend of mine, Leonardo Rafael, tutorial about meta programming in Python at PyCon VE in Berlin next week. And in late May, I'm going to be in Firenze talking at PyCon Italia about Python protocols. And in between those 2 conferences, I'm going to be just bumming around Europe, visiting friends, and so I'm gonna enjoy this long trip. But so this project is my newest project is Jupyturtle. So the story of Jupyturtle is Alan Downey. Alan Downey wrote what I consider the best book for an adult to learn programming, regardless of whether you use Python or not. The book is called Think Python. It's really about algorithmic thinking from the beginning, explaining, logic, variables, and so on. And I was a technical reviewer of the 2nd edition, and now he invited me to review the 3rd edition. And in the 3rd edition, the main change he made was to use Jupyter notebooks throughout the book. Everything is in Jupyter Notebook. And then also, so I would like to ask, how many of you use Jupyter Notebooks frequently? Yeah, okay, the majority. And that's what I expected. And the second new thing that Alan Downey did in the 3rd edition of Think Python is that he always had exercises, but now he has a special category of exercises called Ask the AI, in which he proposes exercises that you should do with the generative AI, helping you develop a solution. So that's very interesting. Anyway, so when I was reviewing the book, so because since the first edition of the book, he's used in a few chapters the turtle model that comes with Python, right? That the turtle graphics. You know, turtle graphics where there's this like abstract turtle on the screen that you command and it draws pictures, right? It's interesting because it makes drawing certain kinds of pictures much easier than doing it with coordinates. So it's a very, very nice complement as a way of making drawings by programming to the usual way of doing it with coordinates. It's more like a polar system, right? Because you tell the turtle to go forward and then turn a certain amount of degrees and so on, and that's how you draw. And so in the third edition, he needed something that would run on the Jupyter notebook, right, inside the Jupyter notebook. And he did some research, found a couple of different libraries, and he was using one of them. And so I was reading the book before it was finished because I was in technical review. And I noticed he wanted to make some changes. There were a few things in the library that he was using that he wanted to change, but the library was difficult to work with. And I looked at it, and I'm very interested in turtle graphics for a long time, because since the 1980s, in the 80s, I taught programming to kids using Logo, which is the original language that had this idea of the turtle. And so I'm very interested in this. And I said, you know what, because he doesn't use all the things that the turtle graphics usually have in the book. So I said, okay, I can do a module. I'm going to steal the best idea of the library that he used, and the idea was to draw inside the Jupyter notebook. What the author did was to generate SVG, right? And then you just display the SVG in Jupyter notebook, and then you have the drawing. It's a very, very good idea. So I stole this idea and I rewrote everything from scratch. The only code that I preserved was actually the drawing of the turtle itself. So let's take a look at it. And then I'm gonna show just a little bit of turtle graphics, and then I'm gonna spend the rest of the time talking about some ideas of Python programming, advanced programming that I use to make it easier for the end user. So it's kind of about meta programming in the service of developer experience, which is actually what we just saw in this amazing talk about Streamlit, right? There's a lot of meta programming going on there. You can be sure about that. So let's take a look at how it works. So this is the repo, right? Where it's published. My account, Ramalho, Jupyturtle, that's where it is. A funny thing, one constraint that I had, I wanted to implement everything in a single Python file, because there are some environments, some cloud environments for running Jupyter Notebook, like Colab, where sometimes when you need a library that's not available there, what they do is they write in the first cell code that downloads the library to the local environment over there in the cloud and then imports it. So in order to make this possible, it's important to have a single file. But this is also something that you can pip install, okay? But the thing is, this file here, Jupyturtle.py, has everything you need. So if you just download this and install, put it on your directory, you're ready to go. So what I'm going to do is I'm going to run Jupyter Notebook here. I was finishing this talk on the train, literally. But now I committed and pushed everything there, so you can see it online. And so this is the root directory of the repository. And now let's take a look at some notebooks. So the first, there's a few experiments. It's all experimental. I love Jupyter notebooks because of, it gives you this environment for experimenting, right? And so I'm gonna start with the lab. So lab is one kind of a free. I use it for different things for myself, but I also kind of give a little technical introduction. Where's the shortcut to Zen mode? Yes, Zen mode is good. Okay, so I'm gonna restart this module. And, actually, I need to restart and clear the outputs, because then we'll see it working. Okay. All right. So from Jupyturtle, import star. This is so some people say, oh, you should never import star. No, this is for different environments, people. Okay, for experimenting, for playing, for doing data science, exploratory data science, you do import star. Okay. If you're doing something, with software engineers that has to be deployed, then you don't do that. All right. But it's okay. It's one of the things why packaging is complicated in Python, because the audience of Python is very broad. So the packaging solutions that work for some of these communities don't work for the others, and that's why we have this problem. But anyway, so it's interesting that you write from Jupyter to import star, and then FD50, and you already have this. Okay? There's a little gray background that we can see here, but there's a little rectangle around here. Okay? So if I run the second cell, notice that the commands were sent to that turtle. So the commands by default are sent to the last turtle that was rendered. Okay? So the turtle is that green thing. And I'm using, because I played a lot with Logo in my life, I got used to this 2-letter command. Okay? So that's what I use. But it's not hard to figure out, right? So it's left, right, forward, stuff like that. Of course, there's also an object-oriented API, right? One of my plans that I have not implemented yet is to do multiple turtles. And for this, it's very interesting to have an object-oriented API, because then you have distinct turtle instances that you're going to command, right? But by default, what happens with the imperative API is that there is a main turtle hidden. And when you send it commands, that's the one that does the work, right? So here I created a turtle with a delay. And you see it takes, the delay is half a second after each step. Okay? And now I completed the triangle. Okay, one thing that's kind of slow is if you want to draw circles, usually it's slow, because you have like 360 is a polygon with 360 sides. But if you turn off the animate parameter of the turtle, then it doesn't do the animation. It just generates the SVG and renders it just once. This can be slow because each segment is a little bit of SVG code that has to be re-rendered every time. Most of the time is actually spent by the browser, not by Python. Because the browser is doing the hard part of, parsing SVG and displaying results. Anyway, but so there's a lot of stuff here that I don't want to show, but I think I gave you the overview of this thing. So now let's go back and see. For instance, there's this gallery here. The gallery, I am slowly building this gallery. Why doesn't it? Oh, yeah. Okay. So the gallery is some interesting drawings. There are classic drawings from books about Logo. Okay, so here's an interesting thing. I created a magic command, right? This thing here, %turtle. It initializes the turtle a Jupyturtle for this cell. So when you want to start a new drawing, you just put that over there, right? And 200 is the size. Because I only specified one number, you cannot see it here because the contrast is low, but there's a square around here, right? If you can specify two numbers. So there's a lot of different drawings here that I'm not gonna show. There's some interesting stuff, like for instance, with recursive algorithms to draw trees. See? Anyway, it's kind of fun to play with this. And here's an example of how complicated things get in the background. To draw that circle, this is the SVG to draw it. Okay? So this is what my Python code generates, and the browser has to deal with it. Anyway, and this explains different ways of doing things and accelerating and so on. But what I want to show you is this other thing here called the turtle trail. Yeah. So this is what I prepared for you. My battery is getting low. We're better for this here. But okay. So this I already told you the story of Alan Downey's book and so on, and then so the kind of the hello world. Let me again clear the output because it's often to watch. I tried different ways of doing this. One alternative that I immediately thought, because I saw that there's this problem of when you do complex drawings with lots of segments, you generate a lot of SVG, right? And so I thought, okay, let's try and use the canvas, because there's an HTML canvas and there's APIs for using the canvas from Jupyter Notebook. The problem is that the official IPyCanvas widget does not preserve the image when you save the notebook. So that's a bummer, right? So that's why I gave up on that approach and came back to the SVG. All right, so now I'm going to talk a little bit about the implementation, right? So what happens here? So you have the turtle, it moved forward 100 units, and now it turned, and then it turned to the right, to the left, but then it moved backwards, and then it turned to the right. That's why it ended in that position, right? And I explained that there is the magic to start a new drawing, right? And then I show this is a simpler SVG that's not so scary, right? So that's the SVG for this is actually the triangle, and this is the turtle. This bit of code I stole from the guy who invented Collab Turtle, right? Because then I really like the way he drew the turtle. Okay, so, and then there's this thing about the fast thing is that is an option. When you send when you give the fast option to the Turtle Magic, it will always generate the whole drawing and not do the animation, right? Okay. So then I talk about the Turtle Magic. So the Turtle Magic works like this. You can pass it no arguments or up to 3 arguments. If one of them is the fast, I explain. I explain already all of this. If it's 2 numbers, then it's the width and the height. If it's just 1 number, then it's a square. Just to generate the sort of the canvas, not a real canvas, but yeah. So the implementation details. I explained about the thing about being a single file, but the thing is interesting is that what I did was, because I was looking at the code of the other author, and there was a lot of duplication because he had an object API, but also had this imperative API, and everything was kind of duplicated. A lot of stuff was duplicated. So how can we do this using metaprogramming so that there's no duplication, or to reduce as much as possible the duplication and make it easier to extend, which is what's happening since I released this. And this is actually now the official library used by the book Think Python. Okay, he adopted the library, and I have a release that was marked at the end of the tech review, and that's the release that he's using. Okay, so what I need to do is to have a way of, oh, I think there's a laser here. Yes, so I need to have a way of having a function like this actually call a method like this. Okay, FD50 call my turtle, whatever turtle, I don't know, dot forward 50, right? And so the way that I did this, so the big explanation, the overall explanation is the turtle commands, which is the name that I gave to the functions that are top level functions that command the turtle, they all do the same thing. The first thing they do is they call a function called getTurtle. And getTurtle gives you the latest turtle that was created, or if there was no turtle created so far, it creates a new one and gives you a reference to that object, right? Yeah, okay. And then it invokes the method on that turtle, right? So actually this becomes something like this. Get turtle, you call it, and you get a turtle, and now you invoke the method on the instance, right? Okay. So the way to do this is one thing. One thing that I tried very hard in my book. My book talks about some complicated stuff in the latest part. So it starts easy. As an intermediate book, it starts easy, I think, for people who already know Python. That's the intended audience. And then it becomes, there's some topics at the end that are pretty complicated. But I tried very hard to make it as easy as I could think. So for instance, decorators, function decorators. Pretty much every tutorial that I found about decorators talk about a decorator that has a code structure that is a function, the name of the decorator, whatever. And then there's an inner function that wraps the function that the decorator is applied to, right? Let's call it the decorated function, right? So there's an inner function that wraps the decorated function to do something before or after, or change or inject argument, whatever, something like that. This is the classic decorator, right? But it's a complicated thing to explain because you have a function that takes a function as an argument and that has a function inside that replaces the decorated function in the global namespace. That's how a decorator works, but it is a lot of moving parts. And so I was thinking, okay, and then I had this idea, okay, actually a decorator does two things that we can explain separately. The first important feature of the decorator is that the decorator is invoked when Python imports a module, it runs the code from top to bottom. It reads the code from top to bottom. It never goes back, just top to bottom. And when it finds a decorator, it says, add something. Then the next function is the next function definition is evaluated, which means now you have a function object. That function object is passed to the decorator, right? So the decorator has an opportunity to look at each function, right? So, and there's lots of frameworks that use a special class of decorator called registration decorators. And those are decorators that don't change the function. You're merely telling the framework, like for instance, some web frameworks have this. You put a decorator to say, this is a view, right? So the framework knows how to, parse the HTTP request and give the arguments necessary for that thing to work, right? So the registration is merely okay, there's this function, and let's remember that this function exists, and it was decorated. So there's this underscore commands dictionary. It's a global variable in the Jupyturtle module. And then the command decorator is just this. It's 2 lines, okay? The first line is, it adds the method name. This is designed to implement, to decorate a method on the turtle class, right? So there's a forward method in the turtle class, and I want to say that's a command, right? So what this does is it adds the name of the method to the commands dictionary and an empty list, because we're going to use the list data, and then returns the method. There's no inner function. Nothing changes in the functionality of the function. We're just taking notes. Okay, there's this function here. All right? Okay. So if, and this is a Jupyter notebook for a reason, because I want to show you running code. At least that was the idea. Let's see if I have run everything that I needed so far. But now I can run this here. Yeah. Okay. So what I just did was I inspected the commands variable, and what it has is names of commands and lists that sometimes are empty or sometimes have alternative spellings, alternative names for the command, right? This is important primarily for the thing about the 2 letters shortcuts, but also it became important for another reason. After I had released the version that Alan Downey started using in his book, I realized that there were, because I followed the names of the methods in the other library that he was using, because I didn't want to change his examples. So there are words like move to and jump to that are written in a way that's not Pythonic. It's kind of, and there's things like that in the standard library as well, right? It's kind of sad. There are, sometimes you have functions in the standard library that have no underscores. But I decided that the canonical name should have underscores. But I also put defined an alias so that the code in his book works as well. Right? All right. So how does this work? So the command alias. This is an example. There's class turtle. There's a lot of methods. Then, for instance, the pen up method is decorated like this: command alias, and then there's the aliases for it, right? So I can also call this. I can also call this pen underscore up or pen up or pu. Yeah. Okay. And then the implementation of command alias is just it takes a list of names, right, or several names, 1 or more names, right? And then this is interesting. There is an inner function here, right? But this is just a registration decorator. The reason why this inner function exists is because if you want your decorator to accept arguments, right? Because usually there is no argument. There's just at command and then the function, and that function will become the argument, right? But if you want to have arguments, then you need to do something like this, because what you have is the public name of the decorator is actually a function that takes the arguments, and then it creates a function that is the actual decorator. All right, and that's just the registration decorator that we just saw, right? And then you return the decorator so that Python can apply it to the decorated function, right? So it's kind of interesting. There is an inner function, but for a different reason than usual. Which means that if you actually want to change the functionality of the function, like many decorators do, and you want to have parameters, then you're going to have 3 levels of functions. That gets complicated really quick. But anyway, so So that's it. So when the code is open, right at the top of the module, I have the definition of the decorators, and then I have the turtle class with some methods decorated. And then below there's some housekeeping stuff. And one of the things that there is the housekeeping stuff does is there's this function called install command. It's always invoked. When you import, it's always invoked. And what it does is it iterates over that dictionary, the underscore commands, and it calls this function called make command, and then calls install command singular. This is plural, singular. And then for each alias, if there are aliases, also install commands with the aliases, right? So make command looks like this. This looks like a decorator, but it's not a decorator. It's just something that is run, it's invoked by the top level of the module when you import. So command gets the unbound method, so the method that's in the class without an instance attached to it, right? This is the unbound method. So I get the attribute name in the turtle class, and this is the method. Then I create this command, which is I get the turtle, and then I invoke the method on that turtle, because this is an unbound method. Is important for the syntax here, because then I can pass the instance as the first argument, and then the rest of the arguments, right? And then I did some things here just to make it better for the documentation and so on. It's not really super important, right? So this is what make command does. And then there is finally install command. And install command has some metaprogramming hack as well, which is, so when I'm about to install a command, the first thing I do is, if the name is already in globals, I raise value error because there's already a command by that name. Okay, that can happen a lot when you're using only 2 letters to define things. Just a little bit of history. I learned to program on a calculator, but then the second thing that I learned to program was a BASIC, was an Apple II computer running BASIC. And at the time, you could give variable names, very long names, okay? But only the first 2 letters were considered. That was a common shortcut, because the machines had 48K, or some machines had, 32K of RAM. So there's some shortcut. But anyway, so if the name is present, we don't accept it. And if not, and this is weird, right? The way to inject things in the global namespace of a module, right? And by the way, this is I didn't plan to say that, but I'm going to say it. A very important trick to understand about Python scoping rules is that there is no global namespace. No such thing. Each module has its own global namespace. It's very interesting. When you understand that, a lot of things start making sense, and you also can come up with some interesting solutions. But anyway, and the right way of accessing that programmatically, if you want, is also always to call the globals built-in function, even if you want to write in it. This is the correct way of doing it. So here I am injecting, I'm creating a global name, and binding it to the function. And the other thing is modules can have a dunder all attribute, right? Dunder is the way we can use those 2 underscores. You will learn that on page 2 of my book. But anyway, so the all module is the use of it is to define what gets imported when a person says from Jupyturtle import star. It's going to import everything that's in the dunder all the names that are listed there, right? So that's what it does. And so this is basically it. I'm going to just, and so I have to confess, I'm 60 years old, but I still program for fun. I did that when I was, learning to program calculators, and I still do it. So, for instance, one thing that I did recently, which was kind of fun, I discovered that there's this thing called Cistercian numerals. Have you heard of that? It's amazing. I'm gonna just I'm gonna run out of cells, and because we are running, and I'm gonna the battery is critically low. Anyway, so these are numbers, people. So the way this this works is this was invented by a monastic order of the Catholic Church in the Middle Ages, right? When they thought, okay, this Roman system of numerals really sucks. Let's try something different. And this is interesting, but it's not, it doesn't come close to the genius of the Arabic numeral system, right? Because with Arabic numerals, we can actually do, summations and other arithmetic, right? With Roman numerals, this you can't. But the thing is, you have, so this is a picture that I got as a reference. I actually kind of made this picture compiling from other sources, but it's like, so you can represent numbers from 1 to 4,000, from 1 to 9,999. And how do you do it? You make a drawing like this if it's 1. If it's 11, you also put a stick below. So like a T on the side is 11, right? If it's 111, then it's going to have another thing over there. And that's how it works. So it's kind of fun. And so I just had fun, thinking, oh, okay, let's do some symmetries here, and how do we play about with that, right? So I did this, and they can also be represented vertically, but I think the horizontal ones are more interesting because they're more different. Look at this. Isn't it great? Look at that. Okay, so this is one key. I wanted to help Alan Downey with a better Turtle module for the Jupyter notebooks, but I also wanted a new toy, and so I built this. All right, and if you want to contribute, there is that's the repository. All right, so that was my talk.
Thank you so much. Questions? One question, please.
And they can be about other things, not just Jupyter.
Okay, here, Rudy.
Why is it a turtle specifically?
Oh, that's a very good question. So the origin of this is at the MIT Artificial Intelligence Lab. There was some researchers there that were interested in understanding how intelligence develops in children. And so one of them, Seymour Papert, came to Switzerland to study with the constructivist guy. What's the name? Piaget. Okay. And one of the things that they did there was to experiment with a syntax for a programming language that evolved into Logo. And because they realized, and this is something that I realized also intuitively teaching programming to beginners, is that the first, one of the first, or the first insight that a person has to have when he or she becomes a programmer is that she needs to start thinking like the machine, to put herself in the place of the machine, right? And the turtle was a physical robot connected with a cable with 2 wheels and a third free wheel, and it had a pen and it drew things in the floor. So they invented this because they wanted to give the children this experience of being able to relate to this object that was controlled by these commands, and so they could do it with the turtle and also do it with themselves. A kid would give commands to another kid, and the other kid would draw. So that's the origin of the turtle. Thank you. Oh yeah, imagine a mechanical turtle moving about in the floor. Yes. Yeah. What else? Yes.
each module has its own global space.
Yes.
If you're looking into the Python interpreter, it itself has a global and a local environment. And if you add something to the global namespace in one module, you probably, or you should be able to call it from another module too. So there is not multiple instances of globals or not a hierarchy of globals, but there should be a one shared global.
Well, the global is the one, when you call globals, open close paren, you get the globals of that module, right? If your module is a client of another module, your module has its own global namespace. And if it wants to reach into the other one, you're going to have to use some kind of Python syntax to do it. You know, an import statement or and qualified names with dots. That's how you reach into the other one. The globals are not embedded one into another. But the locals are, right? Yes. The locals are, you know, the local namespace of a function is embedded in the global namespace of that module. But yeah, good question, thanks.
Good, more questions. It's your chance, meaning of life, whatever. Please.
That's a smaller one. Really cool talk. Thanks a lot. I also loved how you explained decorators. I had to explain to students before, and your explanation is better. To be honest, what kind of contributions are you looking for? Because you brought that up in the module.
Let me think. I was thinking of another thing. There's a.
Did you read the book? Good. Okay.
Okay, the first one is interesting. The second one is hard for anybody but me to do. But there's a third idea that I had the other day. I need to file another issue for that, but I forgot. But one of the ideas that I had when I was struggling with optimizing the drawing of arcs, which I've done with multiple tiny segments, SVG has an arc, a native way of doing arcs, right? And so an interesting problem for somebody that has the necessary math background is, okay, if I am doing a series of movements with the same length and the same angle, after the second one, you already have 3 points and you can derive an arc and implement it with a shorter SVG command that's going to be faster. And then if you add further segments with the same length and the same turn, you can just change a parameter in this thing so it will not grow. So this is a contribution that I think would be kind of neat, you know? But the other thing here, maybe if I start doing this, I can invite contributors, is so my first involvement with Logo was teaching children, but then I was hired by a training company in Brazil, kind of a public-private partnership that's very big, and they wanted to implement. Wanted to to invent a course about logic for programming, something like that. And I think a lot of content that exists out there about logic for programming is kind of sucks, you know, because it's not how I learned, for example. I didn't learn, you know. But anyway, I learned playing. And so I had this, I started doing research. I didn't think that Logo was suitable. But then I found this book called Carol the Robot, which I mentioned there. It's kind of an old book, but it has sort of a turtle on rails. It's a turtle that moves across avenues and streets that form a grid. And then there is objects in there that you have to pick up. I know there's a company, there's a I don't know, an NGO in France called 42.fr. They teach programming from scratch to people for free. It's really interesting, and their enrollment test has something like that. It's something, you know, I just discovered this last year. But anyway, Carol the Robot is 30, 40 years old, and this is so it has lots of exercises involving loops and logic about, for instance, oh, you want to move the turtle, and it's called the robot in that case, move the robot until it finds a red sign and then turn left. Okay, so there's a test to see what the color or something like that. So that was, so I read this on this book. There was no internet for me at the time. It was 85 or something like that. So I didn't have access to the software that was used in the book. But I decided to re-implement it in Logo because it wasn't very hard to do it. So I invented this. In Logo, they have this idea of Logo world. It's sort of like you import something and then you get, it's sort of like what I'm doing here, going back to that. So you import something and then you have an environment that has maybe a special screen and that have special commands and so on. And so and then I called it Logo just because it rhymed with Algol and Cobol. Cobol was important at the time. But so I need to start doing this and then evolve into something else. And there's a third thing that I forgot, but I'm going to file an issue when I remember. Thank you for your interest in contributing.
All right. Do we have more questions? This is like your chat. Yes.
I just wanted to ask you, maybe you like something in recent Python versions, or dislike something like.
Okay, so I like pattern matching, although I explained pattern matching in the second edition of my book, but I haven't taught it to live students. And it's something a little bit that bothers me in pattern matching in Python, because most languages that have pattern, I like Elixir. It's a very interesting language that has pattern matching. But all the other languages that I heard about that have pattern matching were built with that from scratch. So it's very integrated into the syntax of the language. In Python, it is not, it was not, it didn't exist. So it's kind of weird because the syntax of the match expressions looks like Python, but it's not Python. For instance, when you call stir of X, you're not creating an instance of a string with the X argument. You're asserting that X is a string. That's a completely different meaning. The pipe operator, for instance, which we have in Python and in NumPy and pandas, they override it to do interesting things with like a data frame doing Boolean operations with another data frame. Okay, the pipe operator works in Python by calling dunder or, which is a special method, and it's the key idea of Python. The idea that operators invoke methods with standard names, and so that means that you can implement those methods in your own classes, your operators. You can support the operators in your own classes. But when you use a pipe in the pattern, it's completely different. It doesn't invoke the dunder method. So it's interesting. I like it, but there's these problems. Other things, I hated the introduction of the so-called, what's it called, the walrus operator. Okay, but I use it sometimes. But I am, I've been programming for almost 45 years. So, but for teaching, I think that's kind of complicated. I haven't also taught yet an in-person class with that thing. And I actually don't explain it in my book. I just use it sometimes, and I mean, oh, okay, this is the new thing. But I don't really explain how it works. But anyway, typing is something, the static typing thing is a prime example of that thing that I mentioned just in the beginning of the talk about the different communities. Because Python is a huge success, and there's very different communities and very large, but different communities that use it. And so for a certain type of programmer, the type declarations, the type annotations are very important. But I can understand that for a lot of people, that's noise, right? So let's not force that into people that don't need it. Let's be reasonable about that. But I'm going to go even further. Even if your team, you work in a corporate environment where it makes sense to use a static type checker, even as part of your pipeline for building, don't take it like a religion. You know, like for instance, I worked for 8 years at ThoughtWorks, which is a leading company in the agile movement. So they believe a lot, as I do, in testing, automated testing. Don't go for 100%. It's silly to go for 100% coverage, because sometimes you take, you know, it takes too long to get from 97 to 98%, and it's just not worth it. And sometimes you complicate your code just to make it easier to test, which is, you know, so with types is the same. Sometimes there's examples in my book where I actually comment this. So, okay, this implementation became more complicated than I wanted because I wanted to use typing. You know, I needed to, I don't know. There's examples of that in the book. So it's something that I encourage people to use in the correct context. But even in the so-called correct context, I encourage people to use it with, you know, wisdom, and not with dogma. Yes, exactly. Perfect.
I think we need the last question. If we want, and that will be it. Okay. Lucky.
You mentioned meeting up lives, a very broad question that comes to my mind when you mentioned that. Do you have any opinion on Mojo?
No, because I never heard of it. Sorry. Okay, what is it? Mojo. Oh, that other language.
Yeah, exactly. Because
Yes. Yeah. Yeah. I think it's interesting, but I've been you know, for long enough in the IT industry, and particularly following the open source movement, to understand the peril of investing in something that depends on a single company, right? Because you never know when they're going to fold, when they're going to be acquired by somebody else who is going to do something completely different, or change the license, or, you know. So that's the problem. It's just something that when this problem exists in a project, I just don't even go beyond the first page of text about it, because I think it's not worth my time to learn this. This is the way that I deal with this stuff. I wish it was more open. I don't know, maybe it's completely open. The thing is, the openness is delicate, right? Because you can put all your code online, and you can use a permissive license, whatever license, so approved by open, the open source initiative or the GNU Foundation or whatever. But if the decision making is not public, then it's not really open. Because people can make decisions that are going to affect the community in bad ways. And in fact, we can even see an example of this in the Python world. Because, for instance, there was a change about the semantics of when the type annotation, because type annotation, not type annotation, annotations were a syntax introduced in Python 3 without meaning. You could, put colon, whatever, there, and the interpreter just, captured that information and did nothing with it. All right. So that was the way it was, and that's the way that the static typing was developed on top of this of existing syntax. But then later they decide, oh no, we need to do something about these things, because when you have a very large company, and I mean very large, like Google, and you have 1 million servers or 10 million servers running this piece of code, and it imports this thing, and it needs to evaluate the annotations to do nothing with them, it's a waste of energy, right? And so they decided to do, no. So from now on, the interpreter is not going to evaluate the annotations anymore. But that broke code of Pydantic in a way that the author of Pydantic said, no, if this happens, Pydantic is gone. And if Pydantic is gone, Fast API is gone, because Fast API depends on Pydantic, right? And that happened 1 month before the feature freeze that was going to introduce this change. And I'm not saying that Python is not open. It is open. It's completely open, these discussions. But the thing is, sometimes because of the different communities, not everybody is aware of what the other people are thinking. And so the people who work at those very large companies that need to deploy Python code to 1 million servers had this preoccupation that is completely irrelevant to everybody else. And they made a decision that was going to break a very important framework, Fast API. So if it was a closed door environment, that thing would have rolled out and it would have been a terrible panic. So this is something that I think is really important to consider when any new language or framework appears. Is it really open? And by that, it also means, can we actually at least watch, but preferably also participate in the decision-making process, by giving opinions and appropriate mailing lists or whatever.
Amazing, amazing. Thank you so much, Luciano, for your talk and also for this discussion. I think if not the night, we would continue this for hours. Before we say thank you to you and say goodbye, we need to say thank you to a few more people. So me talking this much does not mean that I actually organized it. I mean, I started the meetup, but I didn't do anything for this one. Daniela did. Daniela, come here. So Daniela did
Thank you so much.
behind the scene of this making it happen. Then there is a shy guy over there, Eugene, who is so concentrated on this. Come up here, Eugene. Yes. Then, as I mentioned at the beginning,
this is what he's doing.
This is what he's doing. Behind the scenes, amazing things happen. Thanks for that. And then, as I said at the beginning, we are a big crowd. So without Zeiss hosting us, this wouldn't work out. At least not on this scale. So also a big thanks to Zeiss. Whoever is left here, I think that corner, right? So thanks to you too. Now, if you have these things, can you wave with them? I will just take a selfie with this tool. Okay, can you wave? I don't know if it works. Works? Maybe. All right, I will just do it like this because the key here is also that we all love this, but we only do it because we have a nice feedback. We wouldn't do this without you participating and giving us this feedback. So if you didn't like something, tell us. If you like something about it, tell us as well. We always need more speakers because we are on a fast pace now. We have meetups really scheduled for, Danny?
Until September almost?
Until September almost. We have locations, we do not have enough speakers. So please come to us, talk to us. After September, I assume we will be even bigger. So we need more locations that can host this capacity. Talk to us as well, please. Last but not least, this is a pure community initiative. We are PyMunich. We started 2016, I think. It's just with 10 people, small meetup. Now we also formed an agency around this. These are independent things. Still, these are connected things. So if you want a business partner with IT, please talk to one of us. I'm sure we can make cool things together. So this is also important because this has strong influence on our capacity of organizing this event and the level that we can deliver as a team, as a strong technical background team, and as a good connections that we have in the community. Thanks to you for coming, and I hope that we meet when?
21st of May.
This is a machine. This is better than 21st of May. Where?
At Adesso.
At Adesso. Wonderful. So we still can have one last beer before Zeiss kicks us out. Grab that, and I think we need to leave soonish. So thank you so much. By the way, grab your
Thank you so
books.
much.
Oh, thank you. Amazing.
Let's sign
Was it good? Oh, yeah, sign the
amazing.
book. Yeah, right. I want to talk to the guy who asked the last question.
Sure.
So, was it you that asked the?
Yeah, I totally did.
about is great about open environment. Great answer because I mean I wouldn't call myself a member of the church, but close enough. I have been working